Hello, everyone, and welcome to today's live webinar, Building More Than Just the Pedestal, an owner-developer's perspective on building an all-concrete multifamily mid-rise. My name is John Lee, and I'm the Director of Business Development at Semstone and co-chair of the Minnesota Concrete Council's Build with Strength Committee, one of the sponsors for today's webinar. The Sustainable Structures webinar series was developed cooperatively by the Cast in Place and Precast Concrete Associations from the Midwest region of the U.S., including Iowa, Kansas, Minnesota, Missouri, Nebraska, North Dakota, South Dakota, and Wisconsin. The goal of the cooperative effort is to bring a greater awareness of the sustainable and resilient nature of concrete building systems to the design, construction, and development communities via quality education programs. Today's webinar is the fourth in a series of 5, and I can tell you that so far this series, we've had about 1,350 register for the seminars with about an 80% attendance rate, which is well above the national average. So we are reaching a lot of people about the great benefits from a resilient and sustainable nature of concrete. I invite you to join us again next week for the final webinar in the series. Precast concrete storm shelters will be presented by Paul Todd from Todd Architecture. This presentation has been approved for one AIA learning unit, and it includes HSW credits. Before I turn things over to our presenter, I need to go over a bit of housekeeping. You will have the opportunity to submit text questions to today's presenter by typing in the questions pane of the GoToWebinar control panel that should be located in the upper right hand of your screen. You can submit your questions at any time during the presentation, and we will collect those and address them during the Q&A session at the end of the presentation. Ryan has also provided us a download of the PDF of this presentation, so if you missed a slide or two, you can download that handout. That is also located in the GoToWebinar pane on the right side of your screen. And also a copy of this handout and the recording of the presentation will be posted to the webinar archives on the PCI Midwest and Minnesota Concrete Council websites after the presentation. Attendees who fully participate in today's webinar will be issued a certificate of attendance for 1 professional development hour or 1 AIA learning unit. A link to the certificate will be emailed to you within 10 business days, and if you provided your AIA number when you registered, your attendance will be reported to AIA electronically. You're also going to be getting a survey from us as well, so we'd appreciate any comments that you may have for future presentations and so forth. The course description and learning objectives were listed in the registration process, so I will not take the time to read those now, as I'm sure Ryan will cover every one of those learning objectives and then some. Remember, we will have answer questions at the end of the presentation. And with that, I'd now like to welcome and introduce our presenter, Ryan Bedford, who is the president of Bedford Development based out of Waukesha, Wisconsin. Bedford Development started in 2011 as the development arm of the Kendal Group, a large-scale developer, general contractor, and property manager with over 3,500 units in Illinois, Minnesota, Colorado, and Wisconsin. After completing a successful career as an Olympic and world champion speed skater, Ryan has been active in development since 2010. Ryan, I want to thank you for helping out with us today, and I will now turn it over to you.
Appreciate it, John. Thanks for having me. Hopefully we can be pretty productive today and everybody can learn a little bit more about the world that we see every day in developing our apartments out of concrete. So I am Ryan Bedford with Bedford Development, and all we do in our world is build multifamily. We don't build hotels, we don't build industrial, commercial, office. We just stick to multifamily and for the most part market rate multifamily. So the first question that everybody asks, whether you know kind of what ICF is and what it isn't, we always have to make sure everybody's on the same page on what an insulated concrete form is, or what an ICF wall is. And essentially, it's a concrete wall. And that's what I think a big misconception is around the industry, is that it's some weird new product that people are putting up. when that's not true. It's just a concrete wall. And as soon as you explain it that way, people start to go, that is pretty strong. That's pretty cool. So this is just an example here of a project that we did in Milwaukee using a vertical form product where you can see the inside of the wall, and you can see the rebar. I'm going to use a laser pointer here, but you can see the rebar going in to the wall with the foam on each side. So that's just a basic kind of understanding of what an ICF wall looks like on the inside. And again, you still have the windows that are put in place, the window bucking that is put in place for the windows. Everything easily done with ICF. And as John explained, I was an Olympic speed skater. That was my past career. And I think that this has helped me in this industry always strive to do things better and not always follow what the status quo is. This has led us down the road of trying to always improve on our buildings. And I'll kind of show you that progression as we get ahead here. But ultimately, this all started with my father-in-law, who started the business about 40 years ago. He was always an out-of-the-box thinker. Back in the 80s, he built solar envelope homes, houses that could be heated and cooled all year for about 100, like it said in that article, $120. So he was always ahead of the curve and trying to think of what's smart, what's the best for your bottom line. Again, these motives to find the best avenue is not based on an emotional sense, like I want to do more. It's based on a purely economical sense of I want to save as much money as possible down the road, and I want a product that's going to last forever. So our very first project that we used ICF, it was back in around 2011, and it was a 42 unit in Waukesha, Wisconsin. The idea behind this project was going to be timber frame. We wanted a timber frame looking building, but not an old one with weeping brick walls. We wanted something new, but looked like a timber frame old warehouse. Now you can see that timber framing or cross-laminated timbers are becoming very popular, and I'll talk about that here in a sec. But this is the very first we did in Waukesha. Now, when you talk about sustainability in a project, a lot of people are going towards wood. They're saying, well, wood is a renewable resource, and wood has all these benefits. But when you look at it, when you look at where that wood comes from and where it goes once it gets cut out of the forest and goes to the mill and gets manufactured into a cross-laminated timber, all of that has to be transported, and the footprint that it makes on our environment is huge. And people don't look at that. They just say, well, it's a renewable resource. Yes, but it always is going to continue to break down. And so what we decided to do for our project was not use manufactured timber. Instead, we decided to take our timber on that project out of Chicago, an old warehouse that was torn down, and resawn the timbers and reused them. But again, being able to transport building material in a very short distance, in our scenario was Chicago to Milwaukee, 100 miles maybe, is much more feasible. Just like it is feasible, moving concrete from a concrete plant to a job site is very, very short distance as well. And this is kind of the inside of that project. But again, everything on the outside is ICF with brick and stone, metal panel, exterior facade. And the inside, we were able to kind of replicate that wood timber frame feel of an apartment. Our next project that we did was 115 units down on the river in Milwaukee. This provided different challenges being on the river, but again, we used a lot of insulated concrete form walls where we could. Some of the walls that were buried under the ground are just regular cast-in-place walls, but essentially all the same. This project in particular, we did cast-in-place decks. And so we were able to integrate those cast-in-place decks into the ICF wall which allowed us to thin the size of the deck. Typically, you might see, a 10 to 12 inch cast in place deck on a small parking garage like this. I think we were able to narrow it down to like a 9-inch deck because of all the supporting structure around the outside perimeter holding that deck up. But this is a slightly different scenario, but utilizing the ICF to benefit us, save us some money on the cast in place. This project in particular, we did CMU elevator shafts, CMU stair shafts, and wood interior. The wood and the ICF is basically on the outside. This was the start of us realizing that ICF is very beneficial on your exterior walls, but it is also more than beneficial on the interior walls, whether it's stairwells or elevator shafts, including other support walls, load-bearing walls in a building, and I'll go into that here in a little bit. There's a couple other shots of that. You can see the wood joist in the bottom left. The top is the cast-in-place deck that gets poured, integrated into the ICF wall at that level. The middle picture is of us putting decks onto the outside of the building. This is a huge benefit that we are always overlooking, but in this particular project or with an ICF wall, you can bolt right through it anywhere you want. You don't have load points on the wall like you would on a wood frame building. You have load points all over the wall, and you just bolt it right through the ICF wall, which eliminates a lot of those cables that go from floor to floor, those sorts of things that kind of look odd. It really gives, and I'll show you another deck a little bit later that just provides some really cool looks for hanging balconies. So one of the benefits to using ICF, especially in that last project, was fire rating. Many of you are probably very familiar with fire-rated plywood or even a dense glass that goes on the outside of urban projects to create a fire rating. With zero lot lines, a lot of times you have to have a 2-3 hour rating on your outside wall, and therefore it drives the cost of wood frame construction through the roof, especially in urban environments. So from a mid-rise standpoint that's in an urban environment, the exterior walls going ICF make all the sense in the world. You have your insulation, you have your fire rating, all built into one at a less price than what it would be to have fire rated walls on the outside. It's kind of a finished shot of that project. You can see most of it is brick and stone. And we did do some metal panel up on the top, but most of it's all brick and stone. Now, brick and stone can be applied with the ICF. There's a huge variety of different masonry ties into the ICF walls. And so we used a certain type, but there are many different types that architects can specify. This is another project we did. It's a 78 unit in Green Bay, Wisconsin. Again, in this project, one thing that we did a little bit differently that I always like to point out on this project, because there is the one limitation to ICF is that you have to continue your load points straight up the building. You can't just step the building back. And on this project here, you have your footprint, and I'm going to show it here on this with the pointer. But as you can see, we step the wall back. There's a little terrace there. That terrace is being held up through a parking structure underneath with a series of precast beams. And so that allowed us to go 4 floors of ICF above it, but stepping it back so it looked architecturally pleasing from that side, not just a rectangle. And so there is some things that you can do to offset that load or to carry the load through the building to be able to get that undulation of facade. The other thing that we were able to do on this project is do these stair shafts in ICF. This reduces, in a multifamily setting like this, it reduces noise considerably. it's amazing what kind of sound reverberates through CMU walls. Even if you put a further wall out with wood or steel stud and insulate it, nothing compares to a cast in place wall with ICF. Just nothing compares. So we were able to do that on this project as well. This next shot is again of some hanging balconies. And on this one, we did some corner balconies, which everybody that looks at them goes, these are nuts. How do they hang on the building? Well, they hang on the building because of the ICF. There's really no other way to do it. You couldn't do this with a wood frame building, or I don't know, at least an engineer that would be able to design it that way. You would have to have some sort of middle support. But these are all aluminum balconies that are hanging around the corner of the building. This is one we're just about to start working on in Milwaukee. It's going to be an 11-story ICF building on the water. This project will have all ICF elevators, stair shafts, exterior walls, and the inside is going to be all steel. We are striving to get away from all wood. Wood provides an element of deterioration, an element of concern with mold, water damage. If there is water damage, an internal water damage in the building, let's say a leaky pipe, you never know the extent of water damage unless you fully remediate it. And so we're really striving to get away from all use of wood in a building. But this is one we are going to be working on here very shortly this year. We were supposed to start last year, but because of the pandemic, we delayed it a little bit until this year. So I like to go into the cost comparison, because we always say that it's your first cost is what matters, not your last cost. Because I always use the example of an electric vehicle. If you're buying an electric vehicle for $50,000 and the salesman says, well, it's really not 50, it's 45,000, because you're going to save 5,000 on fuel over the course of 5 years, let's say. My point is, you're still spending 50,000. I don't care if you're going to save 5,000 in the next 5 years. You're spending 50,000, and that's what I care about up front. And I think that's what most developers care about, is the upfront first cost. So I'm going to go through an example here. This is a project that we looked at in Oconomowoc, Wisconsin, a senior living facility. So when we looked at conversion on this project, we looked at how many square feet it was, how that related to wood costs. We had a little bit of insider information on the wood because of the contractor that bid it. And ultimately it came down to about, including the exterior insulation. Now, remember, in this climate zone in Wisconsin, we have to attach a continuous insulation on the exterior of a multifamily. So that is including the exterior foam. And that was $24.48 a square foot. So we looked at it with ICF and wood. So we would do ICF exterior with wood interior, and we came out about $30,000 more than the wood frame. And again, this is just on the framing package. This is not the whole project. The project was massive. It was probably $30+ million. So a $30,000 difference is not much when you talk about a project that big. But when the things that you don't see in the pricing, the ability to pour the stairs and the elevator shaft concurrently with the structure, whereas in a normal building, you have maybe a CMU shaft that goes up, and then you got to build the wood around it. That can all happen concurrently, and you have the soundproofing around those as well. You can eliminate the need for an exterior vapor barrier, a Tyvek, a Typar, some of that stuff. You have greater insulation value with the ICF, plus the added bonus of the thermal mass that you get from the concrete itself. We always tell people that it's like a battery. It stores the heat for the evening or stores the cool for the evening, however you might look at it, depending on what the weather is outside. You can pour in winter conditions. A lot of people ask, well, how do you do these projects in the winter? Well, it's simple. The concrete is insulated all the way up the wall. And so we would have the tops of the walls blanketed, but Other than that, you can pour these in pretty cold conditions. I think we might have ours done all the way down to like 15 degrees. Once it gets colder than that, usually it's the pump operator that calls it off, not the ICF crew. The structural integrity of the walls, right? The hanging balconies, you can put masonry towers right to it, trash chutes, skip hoists, all of those things in the construction element that you can't normally do, or you'd have to get an engineer to sign off on, you can do with ICF. And then obviously it improves the sound transfer through that ICF wall. The last project I showed you, you couldn't see it on that project, the one in Green Bay, but it's right on a highway, major highway. And so people always frown on it. Well, I don't want to live on the highway. They go look at the unit and they're like, man, this is really quiet. I said, yeah, it's because there's concrete walls. So it's just interesting how people kind of miss that. That very first project, that 42 unit, is right across the street from a fire station, and you cannot hear those fire trucks very much. So, and again, I talked about it, but this is an example of the continuous insulation that is required in our area for multifamily, which you can get away from with ICF. And so it benefits you in the heat and the cold. One thing I always tell people is if you're in an environment where the outside temperature swings above and below your living temperature inside, that's the most optimal scenario for ICF. But regardless, it's beneficial in the extreme colds and the extreme heats. So I want to do a cost comparison here on a wood versus steel stud and ICF. This is down in Florida. This is our project we're about to kickstart in Florida. It's a 60-unit project, wood framing with all the tie downs, hurricane tie downs, and everything like that in Florida to meet hurricane code. It's about $24 a square foot. We're able to do the ICF, the precast floors and topping with concrete stairs and all. And then interior steel stud walls. None of them are load bearing. All interior demising walls are ICF. We're able to do it for essentially the same price, $50,000 more. But think of the difference of product that you get for $50,000 on, let's say, a $11 million deal. It's apples and oranges. There's no comparison between the concrete and the wood. So obviously the benefits in the Florida environment is you got disaster resistance. You don't have to worry about hurricanes. It's essentially a hurricane shelter. Mold resistance. You don't have an organic material that's going to mold. It's termite proof and it's energy efficient. Kind of here's an example. I don't know if I think everybody that's on here is from the Midwest, but down in Florida, you have to spray your plates and up your studs, I think 18 inches, with a borate chemical that kills termites if they eat it. So you're introducing an element or a chemical into your living environment that I'm a little unsure of. So just an example there. But disaster resistance, this was kind of a famous photo. I think it was Mexico Beach in Florida. But that house right there, that white house, is an ICF house, withstood the hurricane. You can see some of the other houses are completely gone. That little house in the back behind the white one, I think that one was lucky that its neighbor's house was ICF to block the wind from taking that house out. But you can just see the story that I heard was the guy had to go pick up his stairs to get back into his house, but that was the only thing he was missing. So the other element to this, and this is the back end. So we just talked about first costs in the project and how close it is to wood, and a lot of times it's cheaper depending on the scenario, whether it's continuous insulation, fire rated wood, how the load bearing of the wood is. Many times it is cheaper, and you showed that in those first couple scenarios. Now I'm going to go to the back end costs, right? This is what we look at from an ongoing perspective and how ICF helps us in our ownership. So first is retention. And I'm going to do this math on all four of these scenarios based on 100 units. and just an average 100-unit complex. And so we see, from a retention standpoint, it's really hard to sell ICF to a tenant. You can't, they don't grasp the idea. They might look at the wall and they say, man, this is a thick wall, but they don't understand it, right? You can't dissect it for them and show them what's actually there. And so they don't really see it. When they see it is when they're in the unit. And I've used this example a lot, and I've told many people this story, but we had a tenant in one of our buildings. It was it was an east-facing unit, so it wasn't south-facing. Young gal, and she had moved in about October, let's say. The building was brand new in about September, October-ish, and so she moved in. In late February, it was a cold weekend. Her dad came up, I think, from Chicago to visit. He wanted the heat from 74 to 75 degrees, which is way warmer than I keep my house. And so she called and said, hey, it's not getting up to 75. It's just staying at 74. Can you have someone come look at it? Our property manager sent a maintenance guy out there the next morning, and he calls us back and says, hey, listen, this gas has never been turned on. She went all the way October, November, December, January, and most of the way through February before she even had gas in her unit to fire her furnace. She was obviously just using the fan, the recirculating fan, to push air around, but there was no actual heat coming out of her unit. I had another tenant one time. I was doing a tour of one of our buildings, and a tenant said that the only thing that she needed to do to heat up her unit was to light a couple candles, which was kind of remarkable. But those are the things that make a tenant want to stay. When they don't have those high energy costs for their unit, they feel comfortable, they feel warm. It's not just hot air being pushed around a cold room. They feel it. And so we utilize this from a math standpoint, looking at like 100 units. It costs about $500 a unit to turn over a unit between, painting and cleaning and the possible chance of not being able to rent that unit right away. So from a wood frame standpoint, if we look at an approximate turnover of 30 to 40%, we're able to reduce that in our numbers to about 15 to 25%, depending on the project. All in all, that gives you about a $7,500 increase in your NOI per year if you're able to keep that retention high. The next one thing that we talk about is reserves and deferred maintenance. A lot of times, us as developers, we put about $250 a unit into a reserve fund, and we continue to pump that money in every year. And so what we find is that at the end of the course of time, for instance, that 2011 project, we're not utilizing a reserve fund for things like water damage, for water infiltration on the exterior wall. A lot of times when it gets to that point and you notice things are happening like that, like water damage, it's expensive. It's thousands, sometimes tens of thousands, if not $100,000. We have a wood frame project that we've had to replace all of the windows in because of settling, wood compression. And so we've spent, I think it was over $100,000 on new windows. It was $150,000 on new windows. Those things we're not seeing on these ICF projects. And so therefore, we are able to reduce that in our mind here, reduce that about $7,500 a year on your NOI. The third one is what everybody thinks about when it comes to ICF, and that's energy efficiency. Generally speaking, people say that from an ICF standpoint, you're going to save about 50% of your heating and cooling. Sometimes we see it actually more, especially in a multifamily environment like that. But for us, we only pay for the common areas. We do not pay for our units. Those are tenant paid utilities. So from this standpoint, our common areas, hallways, lobbies, community rooms, fitness rooms are generally about $2,500 a month in heating, cooling, electric bills. And so we're able to cut that in half with ICF. A lot of times they don't actually even run. with the common area, hallway space. A lot of times our rooftop units do not run at all. So again, we're gonna increase the NOI by about $15,000. And so we'll go on to the fourth one. And so the last one is insurance. And this one's kind of a big one that's really starting to come up recently. But we do save about 10 to 15% annually on our premiums from our ICF structures to our wood structures. We see that actually increasing. It's probably closer to 20 to 25% right now in savings, but we're going to use 10 to 15 on this math here. So you save about $400. It's about $400 a year per unit in insurance, and you save 10 to 15%. I think I used 10% here, but $4,000 in NOI. The other element to insurance that's not on here, but it is an upfront cost, is builder's risk insurance. We've seen builder's risk insurance in the recent years skyrocket, and a lot of that is things in our environment, fires, arson. So by building out of concrete, you're able to actually reduce the builder's risk insurance. I've heard all over the board, but I've heard stuff anywhere from 60 to 75% on builder's risk policies nowadays. All in all, with those four elements, from an ownership standpoint, we see about a $34,000 NOI increase to our NOI. And again, remember, those are increases to your NOI with no other deductions. It's a reduction of your expense, and therefore it's an addition to your NOI. And let's say a 5.5 cap, depending on the area you live, that's a $618,000 value. So you just increase the value of your property considerably, and take that first example of that senior living facility, which that was more than 100 units. It's far more than 100 units. I think it was like 250. A $30,000 or $50,000 difference to gain that much more value is pretty remarkable. Now, the reason that project never switched to ICF was because the architect wanted to charge another, I think it was $100,000 to change the plans, and therefore they were already far enough down the road. Scheduling and things would have been an issue. They did not go the route, but they wanted to. Now, last thing is, and this is what we are working on currently, is if the owner is responsible for the utilities, how does that affect what the ownership brings in? And this is where we are looking at trying to figure out how we can make some more money. So from the standpoint of 100 units, and let's say it's $100 average for monthly heating and cooling costs, if we are paying those and we are recouping the savings, we're going to save $60,000 a year. So that's another $60,000 to the NOI. The other thing you got to keep in mind here is most utilities, at least here in Wisconsin and other places we build, they charge, I think it's like $7-8 for a gas meter and $7 or $8 for an electric meter. So every month the tenant is going to pay, call it $15 on their bill for just having a meter. When you reduce all of those on a 100 unit project, you're going to have 200 meters, gas, 100 gas, 100 electric. That's a lot of money that's just being sent to the power companies to pay for nothing. They're not paying for any electricity or any gas with those. So this is something that we are exploring, but for senior living, for hotels, this is a huge, huge benefit, much greater than the other four combined. This is a huge benefit for owners. So at that, I'll kind of leave you with this picture of this project that we did in Green Bay. Again, the facade is kind of endless in what you can do with it: stone, metal panel, hardy board, brick, whatever, EFS, whatever you may. The possibilities are endless with ICF, and we believe it really is the best and most effective product out there to build with. I'll turn it over to you, John.
Thank you very much, Ryan. We've got a lot of questions that have come in. I think, we've got about 25 minutes left, so certainly don't worry about running out of time here. If you've got questions that you want to ask Ryan, please send them our way. I think what I'll do is just kind of start on the list here. And I've got a question here about, and you kind of talked about it, maybe you can just kind of, just maybe give a brief um, recap on what is the approximate install cost per square foot for the ICF wall, and then also kind of, labor versus materials. What have you seen in terms of the cost for labor, the cost for materials, and maybe what the overall per square foot cost is? Granted, we know that, we've got a lot of people here from across the from the upper Midwest, but in where you've done your projects, where have those numbers kind of been?
Yeah, that's always a good question. So typically from a per square foot on the wall, you're going to see stuff probably in the $15 to $17 a square foot on a standard build. And the reason I say that is because as soon as you start introducing different elements to it, like, different types of window bucks, or, an excessive amount of rebar, or you want a 12-inch wall over a 6 or 8-inch wall, those things start to creep the price up a little higher. But the standard 6 to 8-inch wall with standard rebar, nothing out of the ordinary, for instance, exactly what you're looking at here, we're probably in that $15 to $16 a square foot. Now, if you take from a CMU comparable standpoint, in the city of Milwaukee, or around the city of Milwaukee, we are about $16 to $17 per CMU per square foot. And so you're talking, it's almost the same thing. You're getting almost nothing compared to what an ICF wall gets. And to go back to from a per square foot basis on labor or materials, typically the ICF material is between $3 to $3.50. Concrete's going to be about 2.5 to, call it 3.5, depending on the location you're in. It's very cheap in Milwaukee. I think we're about $85 to $90 a yard. Some places go up to, I was just out in Colorado and guy told me it was $200 a yard. So it depends on the area. And then labor is going to range depending on the project, depending on how much rebar is in the wall and those window specifications. You're going to be someplace, I would say, between $6 to $9 or $10 a square foot, based on that.
Okay. And for those that want to get more information on that, if you go to the MCC's website, back on January 6th, we had a presentation that addressed that topic very specifically. So that presentation is archived. Question on, have you done 179D energy certification studies on ICF? And have you received the full $1.80 per square foot? Are you familiar with that?
I am not overly familiar with that, but this project here on the screen right there was a HUD 221D4 loan. And with a 221D4 HUD loan, you have to meet, or to receive a reduction in your interest rate, you have to meet an energy standard, either through Energy Star, LEED, National Green Building Standard. And so we decided to go National Green Building Standard route. I believe it was, I know I'm going to forget this, but it's either gold, or it's either bronze or silver certified through National Green Building Standard. And a majority of the points that were received were because of the exterior wall. Obviously, it takes into effect windows and roof and HVAC equipment and appliances, those sorts of things. But a majority of the points based on the calculation system was done on the wall. Okay.
Question on stair shafts and the use of one-sided ICFs for interior walls, such as a stair shaft, and then even like in your parking garages. Now, I've toured one of your I toured the Milwaukee building, and maybe talk a little bit about just covering the ICFs when you've needed to do that.
Yeah, so the from a stairwell standpoint, I think all that is needed is 1/4 inch drywall to cover the foam from a fire rating standpoint. Again, foam is not flammable, but it's toxic if a flame hits it. Therefore, it needs to be covered so that if there is a flame in a stairwell, let's say, or anywhere, it doesn't kill the occupant in the unit from a toxic, output. So we typically do about I think it's a 1/2 inch drywall over the ICF wall in the stairwells. It provides just a fine finish inside the stairwell. From a parking garage standpoint, everybody asks this question, and I wish I actually had a picture in here, but I don't. We put metal panel, the very cheap exposed fastener metal, vertical metal panel in our parking garages. We first put 1/2 inch OSB. The 1/2 inch OSB gives us the fire rating we would need, or the fire resistance to the foam that we would need. It's not necessarily a fire rating. And then we put the metal panel over it. And in a parking garage, it's typically the same height all the way around the parking garage. Therefore, we have all the panels pre-cut. They come in there and they just start slapping panels to the wall. The nice thing about this from an ownership standpoint is when we go in to pressure wash our parking garages, they're able to pressure wash the wall with the floor and get everything, cobwebs and all. They're able to wash it down. It also, if it's in a basement, there's no windows in that parking garage, it provides a very bright surface. So the light reflects off of it. It's very safe and bright. The tenants feel a little bit more welcomed by it than having a dark, kind of dingy garage.
Okay. Let's talk a little bit about architects. First of all, have you had any issues in finding an architect to design with ICFs? And then another question, very similar, would be kind of chicken or the egg. Do you find an ICF friendly architect, or does the ICF friendly architect find you?
Yeah, those are good questions. So we haven't really run into an architect that has been too bad to work with from an ICF standpoint. I mean, the key is, keep it simple, stupid, right? It's a concrete wall. No matter how you want to cover it, it's still a concrete wall. And as long as they understand that simplicity behind it, it's not hard to engineer. I always tell people, though, you're much better off with an architect that has either in-house structural or has some structural background as part of their education, because when you're lining things up, for instance, we go through the very preliminary designs of some of our buildings. When we're lining those load points up, it's very good to have a structural engineer that knows what they're doing to help lay out different units and where the demising walls are going to load down to the lower floors and how those things work out, because it can work. You just have to design it from the beginning that way. It's whether the architects I don't think the architects ever found us. We always look for the architect, but there are many good architects out there that do a lot of ICF, and those that don't, they can be educated and taught how to use ICF or how to design with ICF.
Great. You mentioned structural engineers. Let's talk about them a little bit. If we specify ICF for our project, what is required on the structural drawings? I assume ICF is a specialized material that is designed by the ICF supplier. Any thoughts on, just from that structural engineering standpoint, some things that they may need to be concerned with?
To answer that pretty quickly, the answer is no. Again, it's just a concrete wall. So just as they would design the foundation wall, they would design the rest of the walls going up with the lintels for the openings and such. That structural engineer would, would engineer all the reinforcing and the spec of the concrete that goes in the wall and what the size of the aggregate and the strength of the mixes. But really, it's just an ICF wall. The manufacturers themselves are just providing the forms in which the concrete goes. A lot of it more relies on the ready mix plant that is going to produce the concrete, making sure that it's up to spec from the structural engineer.
And I think I could even answer that too. Many of the ICF manufacturers also have all the necessary detailing as far as windows, doors, various connections with flooring systems, things of that nature. So a lot of the ICF manufacturers already have those details kind of drawn up that the structural engineer, the architect can use those in their design. Let's see here. Here's one about contractors, and this one made me laugh. I find that contractors tend to abuse the ICF forms once they are in place before the protective claddings are installed. Other than threatening death, is there something you can do to reduce the damage?
That's a good question. We've never had that on our projects. I mean, you get people that write on the walls, like plumbers and things will write on the walls with a Sharpie for measurements on their pipe that they're working on next to it. They may have pictures on the walls. Some guys I've seen draw pictures, but I've never actually seen anybody damage the wall or try to hit it. It is hard to destroy. If you had an ICF wall and you punched it as hard as you possibly could, you're going to leave a little indentation, but it's not going to affect the wall, right? If you're going to put drywall over it or some cladding or anything, it's very hard to actually destroy the foam. The only time I've ever seen it is someone ran into it with a machine. But from that standpoint, I think it's pretty durable. Once you get that foam and once you get the concrete in the wall, it's pretty dense.
Yeah, and I think the other thing about that is the fact that it's easily repaired too. If you do have gouges, things of that nature, it's easy to repair those. And and a question that I have for you would be, how have speaking of subcontractors, how have they looked at it from your plumbers, electricals, because those are the trades that are going to be working in this after the concrete's been placed. What kind of response have you gotten there?
Yeah, so the subs are, a lot of times they're a little weary up front, but about a 5 to 10 minute conversation with them kind of eases those concerns. From an electrical standpoint, the electricians on most of our projects are really the only ones that go in the ICF wall. A lot of times the plumbing, HVAC isn't really affected. HVAC, you do have a lot of penetrations through the outside wall, and as long as that's coordinated with the ICF contractor, those penetrations can be placed in the wall wherever the HVAC contractor would like. But electricians are really the only ones, and there's multiple different methods to cutting the foam to placing it. But ultimately, you don't have to worry about drafting. A lot of times, in an electrical outlet that's on an outside wall, that box has to be draft proofed with either caulk or some sort of spray foam. The electrician has to make sure it's airtight, just so you're not getting drafting through an outside outlet. On an ICF system, you're mounting the box right directly to the concrete after the foam is cut off. And that cutting of the foam is very easy. And a lot of times they look at it and go, I'd rather cut this foam than cut through a bunch of studs. So 5-10 minutes of conversation with them on how to do it. It's a no-brainer.
Okay. Let's talk about floor systems here. I think I got a number of questions on this. Let's talk about how, as far as mid-rise structures, say 10 stories, what type of flooring system would you typically see? And then also maybe commenting on the integration of post-tension concrete slabs, and then maybe comment on precast hollow core.
Yeah, so on a 10-story, our 10-story that or 11-story that we're working on is all going to be cold form joists on the inside. We're working on another project currently that's breaking ground next month that is all going to be an EcoSpan or new core product, a bar joist with concrete over. Again, both of those floor systems are with a 3 to 4 inch concrete slab over the joist and the metal decking. And the main reason for that is anybody that's in multifamily is going to tell you their number one problem is sound. And that's why we are migrating in this direction of getting away from all wood. Wood is not a friend for sound. It does a terrible job. And so as you get to the concrete, you provide a much higher SDC rating. and that's why we're moving that direction on all of our projects. So the cold form steel stud floor system, or the like an EcoSpan bar joist, those can just sit right on top of the wall. They get poured right into the wall at the very top of each floor. Those are very easy to do. I recommend that, especially if you don't want a heavy building. And you also, in a multifamily sense like this, you don't want to have drop ceilings, right? You want to run everything up in the joist space, all your mechanicals, plumbing, electrical, all up in the joist space. You don't want to drop the ceiling. When you go to a precast or even a post-tension, you're going to have to drop the ceiling below that hard deck to get mechanicals to run through there. And so, that provides a different challenge if it was more of an office, school office building. When you're going to drop the ceiling anyways with an acoustical ceiling, that doesn't matter. I'd rather go with a precast or a post-tension over a steel deck. We've used it many times with precast. Precast typically requires about a 3-inch bearing on the ICF wall. That's on the concrete of the ICF wall. So if you go in a 2-direction, you got precast going one way and the other way. We typically do an 8-inch wall to bear two planks in 2 directions. And then a post-tension, it works well in post-tension as well. We're that 11-story, the first 4 levels are post-tension, and we're going to be doing post-tension through that ICF wall as it goes up.
Okay. You mentioned precast, and with the push for industrialized construction, prefabrication, and have you looked at, for some of these buildings, looking at like structural or architectural precast concrete? What are your kind of opinions on that?
Well, from a precast standpoint, if you're talking about a wall comparison, right, a tilt-up wall, precast wall comparison versus ICF, yes, the precast is faster, and it's a more finished product right away on the exterior. ICF carries far more benefits from an insulation standpoint. So I see one. There are two different. There's 2 different ways to look at it, and I really don't think from a multifamily standpoint or a housing standpoint you would ever use precast tilt up walls. The cool thing in ICF is there's a lot of guys, and our guys are going in the route of prefabbed ICF walls. Now that's not poured ICF walls, but the panels themselves are prefabbed, where they get shipped to a job site, they get set up, and they get poured immediately after being installed on the job site, so which is going to speed up construction time.
Okay. Let's talk about, have you had a unique challenge with ICFs that you had to come up with a solution? And if you could, maybe just talk about that, as you started to build with these.
Yeah, I would say the most unique thing that we have to do, and it's early on, is on the design side. Really trying to manipulate the design of a project where you're kind of going against the grain of what is standard. I'm going to use an example here. Most parking garages underneath a 1, 2, 3-story, 4-story, 5-story building are going to have, if it's a precast deck, they're going to have the beams running parallel with the drive aisle. We are now designing buildings where they are running perpendicular with the drive aisle. You'd say parallel with the parking stalls on each side. You got a 60-foot wide building. The reason we're doing that is so that the internal demising walls can be ICF, and that load can transfer all the way down. Now, most people, or no one that I know of, has parking garages that are designed that way. It's just not the status quo. So a lot of times you're just kind of thinking of these things from an early design standpoint. How can we make this work? Everything is possible if you look at it early enough. If you get too far down the road, it's hard to turn back. because you're looking at how much money you have into it. But if you catch it early and you can design it in an effective and efficient manner early, you're going to save money and be able to do what you want to do.
Okay. How about talking about cost analysis of demising walls, firewalls between units, corridor walls compared to wood and steel stud? Any thoughts on that?
Yeah, so we're using the demising walls mainly for sound and for load. Even though they're ICF, we could go with a standard cast in place wall or a CMU wall, you might say, for those demising walls. We decided to go with ICF because, one, it is fully integrated to the outside wall. It's all poured continuously, and you're getting that that insulation that you can apply. You don't have to do furring strips to put drywall on. You can apply the drywall right to the ICF. So we see that benefit is really there. I mean, if you're talking a demising wall with no openings in it, the cost per square foot on that section of wall is going to drop considerably. You might be in the, call it $13 to $14 a square foot range on an interior demising wall with no windows or doors in it, versus an exterior wall with all the punched openings. So it becomes much cheaper on some of those demising walls than what you would actually think. And it helps your floor system.
All right. What are some of the key energy efficiency measures do you consider the most cost effective? I guess we've obviously talked about ICFs, but are there other things that you consider as you're embarking on a project?
Yeah, the other elements, or the two other elements, are pretty obvious. Those are your windows and your roof. The windows are the weakest link in this whole process for us, and so we always look to get some of the most efficient windows we can find. That really is the weak point. And even when it comes to sound, windows are the weak point. So you want to make sure that they have the right ratings for those windows as well. If you're up against a sound issue like we were on this project next to the freeway, but the roof as well. A lot of people neglect the roof. They're like, oh, we can just throw some couple inches or have meet the minimum standard. On this project right here, we did anywhere from 24 to 48 inches of completely filled joist space up on the roof, blown in insulation. So, I mean, our value is, I can't even tell you what it is per inch, but it's got to be R 60, 70, 80, maybe 100 up there on the roof. So, those are the two elements that we look at. What I find I'll mention this too, is a lot of HVAC designers don't understand ICF. And so they'll over-engineer the HVAC system, and what we find is that the HVAC systems are not used. They just aren't used to the capacity in which they are designed for, because the ICF or the HVAC engineer didn't understand the exterior component. So really kind of meshing those two together. Don't buy more than what you need from an HVAC standpoint.
Yeah, that's interesting you make that comment, because I know you've presented with Mark Ginsberg from Ginsberg Curtis, and he spoke at MCC, I think it was last year or 2019, and he said the same exact thing, that you need to make sure that you marry up your mechanical engineering with the type of wall that you're using so that your HVAC systems are used efficiently. I think maybe one last question here. Is what advice would you give to developers who are considering using ICFs for the first time?
I would say explore it as much as possible and look at all the viable options. Talk to everybody in the industry. There's so many people in the ICF industry, whether it's manufacturers of the product. There's couple big companies out there that have plenty of resources, but there's also the National Concrete Ready Mix Association, and all these different groups that can help, right? Even right down to your local ready mix. They're willing to help and get you the proper resources that can lead you in the right direction. There's so many different things that that can really help. And so for us, it was really taking a jump when we didn't have those resources. We didn't know about the NRMCA. We didn't know about contacting our local Ready Mix association or Ready Mix. We didn't know any of that. We just jumped into it. And so not saying that you shouldn't just jump into it, but you have the resources out there to use, and I would utilize them.
All right. Once again, thank you very much, Ryan, for your time. Again, folks, this webinar will be, once Margaret gets it processed, will be put onto the MCC website. In the, I believe I put in the chat to everybody, I put a link to the Minnesota Concrete Council's archives of webinars, and there you can view the webinars that have been previously recorded, as well as download the PDF documents that we were provided. And so again, I thank you very much, and we hope to see you next week for the 5th and final Sustainable Structures series webinar. Everybody have yourselves a great day.